Hello all and welcome to this video on looking at gallery of graphs circles. So it's from exercise 4D in the textbook, but we're going to be focusing on circles and we'll also get to semicircles at one stage. So hopefully we all know what a circle looks like. Big round shape. The equation for it, and the most basic one, is x squared plus y squared equals 1. Okay? So this is a little different to every other function or graph we've looked at so far, in that the x and the y are on the same side of the equation. Now, of course, we could write this as y squared equals 1 minus x squared. We could do that, and we'll get to something similar to this when we start looking at semicircles. But the general form, the most recognizable form, is when it is like this, when we have an x squared and a y squared, same side of the equation. Now, where does this come from? Well, this can come from using Pythagoras' theorem. Okay, so if we pick a random point on this circle anywhere, let's say we pick point P at coordinate x, y, we end up with something like this to get to that point there, where we have an x coordinate and a y coordinate. Now in this case, this circle has a radius 1, so we can substitute all those values in to, we know for this triangle it has to be a right angled triangle, so we have the equation a squared plus b squared equals c squared. We substitute our values in, x, y, and 1, and we get x squared plus y. Now to take it a step further, if we change this radius from 1, we can change it to any radius r. Well, if we substitute an r in there, this becomes r squared, and we get this more generalized form of a x squared plus y r squared. The big hint that points out that you're dealing with a circle, okay, in these problems compared to all the other graphs we've looked at, is we have squared terms for both x and y. That just screams circle. If you see that, you need to start. So the general form, just like everything else we've looked at, we have x minus h all squared plus y minus k all squared equals r squared, where h is the horizontal translation, just like normal, and k is the vertical translation, normal. R is the radius of the circle, so it changes its size. So we don't have really a dilation or a reflection, okay, because it's a whole circle. If we flip it, it still looks identical. If we flip it horizontally, it still looks identical. Now the dilation, you could sort of argue that the r is acting like a dilation, that it makes it bigger or smaller, but it's not quite squishing. Like if you think of the truncus or the hyperbola, the dilation squishes it in at certain points or stretches it out near the origin or the intersect of our asymptotes, while the radius in this case is a nice scale. It stretches both horizontally and vertically the exact same amount. It keeps it circular in shape. It doesn't turn it into an oval. So where to from here? So let's have a quick little look at translations, because that's what we're going to deal with most with a circle. We can deal with translation. So let's have a look at some previous translations, and then what happens in we do it with a circle. So real quickly, if you remember the long way, if you aren't just reading off the h value, but with the truncus, hyperbola from exercise 4a, you'd let the bottom, or the denominator of the fraction, equal to 0, solve for x, that gives you your h value. That's its horizontal translation. With the truncus, same deal. Okay, we let the denominator inside the square equal to 0, solve for x, that gives our h value. That tells us our horizontal translation. Square root graph, we let the terms inside the square root sign equal to 0, solve for x, that gives us our h value, which is horizontal translation. Of course, all of these can also just be done knowing that this system pardon me, sorry, you could just read off the h value. The h value comes from doing this process. Okay. We can do the exact same thing with the circle. So let's have a quick look. So a quick translation summary: state the name of the graph given by the rule, state both the vertical and horizontal translations, and then give a rough sketch. So I'm asking for a rough sketch, not a full proper sketch with like intercepts. So having look at this, okay, we have a fraction and we have a square. So to me, and the y isn't squared because that we now need to look at that to determine if we're dealing, as soon as we see a square, anything, are we dealing with a circle or not? In this case we aren't, so this is a truncus. Okay, the vertical translation is 1, and the horizontal translation we can read here, need to switch the sign, that is going to be, or if we did it properly, it's x plus 3 equals 0, x equals -3. So let's go with quick sketch, h of x -3, y equals 1, and it is a positive truncus, so get something like that. Now that is quite clearly not the best truncus I've ever drawn, but it'll do. We're just doing a rough sketch. We're working on translations. Okie dokie. So this one, y equals 5 minus 2 root x plus 1. Well, we got a square root. There's no y squared term, so it's a square root graph. I'm going to rearrange this just to be more standard looking, just so we're used to it. Okay, so name, square root. Okay, vertical translation, well, plus 5, that's easy. Okay, horizontal, if we do this properly, we do x plus 1 equals 0 equals -1. That means our h is so up 5, change this, that's up 5, each block is 2, and same across, going across is 2, so right there is our starting point. 5 just in scale. Now it's a negative square root graph, so that means it's going down, so it's something like that. Let's do a couple more. Okay, 1 on 2 minus x plus 4. So we have a fraction with our x value in the denominator. It's not squared. That must mean it is a hyperbola. Now the vertical, easy, that's a plus 4. Horizontal translation, while we let the denominator equal to 0. Don't have that, so we get 2 equals x. So that means our h is equal to 2. So go x is equal to 2, y is equal to 4. Okay, and it's a regular hyperbola, so up in there, something around there. And hopefully by this stage, this topic, we've been going at it for a bit over a week and a half. You're building this fluency with recognizing the forms and finding the translation. By this stage, you need to put in a bit more practice. Okay, now this one, oh, it's new. X minus 3 all squared, y plus 4 all squared. So we've got a, importantly, x squared and a y squared. Even if we expand the brackets, that means we have a circle. Okay, so the vertical, okay, same deal inside this bracket. We're just going to, just like we've been doing all the horizontal, this time we have to do it for the vertical as well. Y plus 4 equals 0, y equals -4 is equal to -4. Do the same with horizontal, x minus 3 equals 0, x equals 3, so h is equal to, you can get used to reading this off, but this is just to show where it comes from. Okay, so -4, h is 3, so across 3, down 4, There's our center. Okay, now just quickly, it's going to be equal to r squared, r squared 4, so r is equal to 4 is equal to a radius of 2, cross 2. Our circle looks like that. Now I'll show you more about this radius in a second and how to come up with this. Quite possibly the worst potato looking, but you get the idea. Okay, so we've looked at how to find the center. We found our center there. We let a horizontal, our x value, bracket equal to 0, and then we do the same for our y. Okay. We can see from the rule above that rule for a circle that gives the radius given by r. Okay, and it's important to note that when given a question, you must square root the number after the equal sign to get the radius. So what I mean by this is when we look at this, our radius is not equal to 36. Okay? When it's written like this, when we can't see a squared symbol there, r squared is equal to 6. So here, r squared is 6. R squared is equal to 36, therefore r is equal to 6. So r root of 36 is equal to plus 6. Okay. As it says here, okay, 36 plus or minus root 6, we reject the negative 6 as the radius because, well, we can't have a negative. That shape doesn't exist. Positive. In this one, again, we can see okay, there's no term here in the y, so we have rk is equal to 0. Here, rh is equal to 2. Now, a really important part to notice, back before I go any further, just like in all the other equations, we have a minus h. So in this case, we have a negative 2, so we effectively get to switch the sign when we read this off, so our h is positive 2. For the first time ever, we now have that for our k value as well. It's minus k, so we have to switch our k value when we're dealing with circles. Fine. So let's have a look at, let's form some equations or read off some equations before we get into some full-on graphing. Write down the equation of the circle with the center 1, negative 2, and radius 3. So we have x minus h all squared plus I minus k all squared equals r squared. Substitute in our values, we can write it off here. H is equal to 1, k is equal to negative 2. In, get x minus 1 all squared plus y minus negative 2 all squared equals, we have r equals 3 equals 9. Okay, and I'm showing this the long way just to show the working out with the signs, and importantly show that our k sign has swapped. Y plus 2 squared equals 9. Okay, it was negative 2, we write it in as positive. Write down the center and radius of the circle with the equation x minus 2, y plus 4 equals 20. So, in this case, we have h equals 2 equals negative 4, and our radius is going to be the square root of 20, which is 2 root 4 root 5, so it's equal to 2 root 5. So it follows on, our center is 2 negative 4, and our radius is equal to 2 root 5. Easy. Write down the equation of a circle with the center 0, 1, and a radius of root 5. Okay, so h equals 0, k equals 1, r equals 5. Write down our equation, just get used to this, plus minus k all squared equals squared. Substitute in your values, x minus 0 all squared plus y minus 1 all squared equals root 5 squared. Simplify this, x squared plus y minus 1 all squared equals square root of 5 all squared is 5. Okay, so it's just like what we've been dealing with. We have a h value, we have a k value. We don't have a dilation, but we do have a radius which acts very similar. We can treat it effectively the same way in our process. So let's do some sketching. That's what we've been building for. Sketch the graph of the circle with the equation x minus 1 all squared plus y plus 1 all squared equals 4. You must also label the center of the circle, label all intercepts where appropriate. So there's a couple non-negotiables. Like every other graph, to properly convey the information, we need to label some certain points. You need to label the center. Okay. We're actually going to draw in the radius, and I'll show you how to do that in a second. And you need to label any intercepts. Cool. So there's a bit of a hint here. When first starting, find the compass points of your circle. Mark the center. To do that, you mark the center point on your axis, and then using the radius, find the very top. Mark that in, and then do that again for the bottom, the left, and the right. Sketch the circle, and then add in your intercept values as you find them. The intercept values are generally for a circle not very nice. They come out as surds, but you just need to estimate them in your sketch. You need to find them the exact value, but estimate roughly where they are in the sketch. So let's have a go. Straight off the bat, we get h equals 1, a equals -1, and radius equals the square root of 4 is equal to 2. Okay, so we get to sketch in our center point. I'm going to put that as a big red dot. Go across 1, down 1. Okay, there's my center point. Sketch that in. Okay, now, and I may as well label it quick. 1. Our radius is 2. That means every point on this circle needs to be 2 away from that. So what we can do, okay, is just like it says up here, is sort of our compass points. We're going to find the north point, the east point, the south point, the west point, or the top, right side, bottom, left, just by going up 2, across 2, down 2, and left 2. So that's up 2 from my center. Furthest right will be right 2 from the center, down 2 from the center, and across 2 left from the center. Okay. We now have points we can roughly, I'm going to do this, it's pretty hard. Okay, and I did that by just finding the compass points. I didn't find any. It's pretty easy to read off. Up that far, across that far, left that far. Okay, you don't need to label all these points. You don't need to label all these points. What you do need to do is up here, okay, instead of labeling all those points, okay, because they aren't intercepts, you could use them as point of reference, but it's much easier if you just label a radius. So all you do, draw a line out, put a little arrowhead. That gives you a sense that you know all those points are a radius of 2 away from it. And the last thing left is to find the intercepts. So let's at least mark them. They're all intercepts. And this is why, in this case, unlike all the other graphs, how we found intercepts first, a bit easier this time is to mark them, and then we can just label them. As long as we've drawn our sketch to the roughly right scale, it's all going to work. So I need to find these 4 points. So, okay, let's do the x-intercept. So we let y equal to 0 like normal. So we get x minus 1 all squared plus 0 plus 1 squared equals 4. X minus 1 all squared equals 1 squared is 1. Take away from both sides, so that gives me 3. x minus 1 equals plus or minus the square root of 3. This is where we need to keep the plus or minus because we're not actually finding the radius, we're finding points. So if you take the square root, you need to keep the plus or minus because, and we need it because it's going to be 1, 2 points, and this is where the idea of 2 comes from. So x is equal to plus or minus root 3 plus 1. Okay, so that means this point out here, okay, would be the positive root 3 plus 1, and because that gives you a positive number, and then it must be this one over here is negative root 3 then plus 1, roughly about that value. You could always check this, put in your calculator. You're not going to be able to use your calculator in the test, but you can always check when you're first doing these to get a sense of scale and size, and if putting negative root 3 plus 1 gives you a negative decimal. What was that? Root 3 plus 1, 0 was negative root 3 plus 1 comma 0. Okay. So that's our x-intercepts. Now we're going to do our y-intercepts exactly the same way. So we let x equals 0. So we get 0 minus 1 all squared plus y plus 1 squared equals 4. So we get negative 1 all squared is 1. Take away 3, take away from 4, sorry, is equal to 3. So we get the same thing, y plus 1 is equal to plus or minus the square root of 3, y equals plus or minus root 3, take away. Okay, so same thing, root 3 is roughly 1 point something, take away 1, that gives you point something, maybe 0.7. That works for that one, happy days. Negative root 3, that's roughly negative 1.7, take away another 1. That's going to be negative 2.7-ish, which is down here, so that's worked out perfect. So we get, this would be root 3 minus, oh no, 0 for our x value, root 3 minus 1, and then down here we get negative root 3 minus, the same thing, 0 for x value, and our y value is negative root 3 minus 1. There we go, there's our sketch. So to review quickly what we did, we found the center first, and then plotted, okay, our compass points. So highest point, furthest left, furthest down, furthest right, and then drew our sketch. We then labeled the radius, and then we found our intercepts. We got multiple values for x and y, as when we take the square root of both sides, we get a plus. Okay. I'm going to leave this one for you to try, use the exact same process. So while you have a go, just pause the video because I'm going to go right on to the next slide. So just like we've seen in other graphs, we can write these graphs in non-standard form. Okay? So we've seen this before with the rectangular hyperbola. We have this x on top. Okay, we need only to have the x in the denominator, so you need to rearrange that. We've been through that. This truncus, this looks very close to a perfect truncus. Problem is it has this 2 inside the bracket. The general form or standard form that we're used to is 1 on a over x plus, sorry, x minus h all squared plus. Okay, there shouldn't be a coefficient inside, and we've shown you how to get rid of that. Now, we also have non-standard form of a circle. How do you recognize a non-standard form of a circle compared to all of these others? We have an x squared term and we have a y squared term. As soon as you see x squared and a y squared, you know it's a circle. Okay, you know it's a circle, and then we just have to get it to look like a circle. Okay, so we need to be able to convert it into this general form down here. How do we do that? How do we do that? Well, okay, we're going to use completing the square. Now I know some of you still don't like completing the square, but you have to use it, and you have to use it twice in here. Okay, so I'll show you how we do this. Now, used some color here to help try and make this a bit clearer. Okay. Your notes, I can't remember if they're printed in color or black and white. They might be in black and white, so I suggest you go and grab yourself a highlighter and highlight each of these sections in different colors so it makes it clear. So any terms with x in them, we make one color, so our x squared and our negative 2x. Any terms with y in it, we group them together as one color, so y squared and the 6y. And then any constants, so negative 15 and negative 4 or plus 8, anything that doesn't have a variable in it, an x or a y, we make that a third different. The next step, we need to group all this together. Okay, so we group our x's together first, x squared minus 2x. We then group our y's, y squared plus 6y, and then we actually move our constants to the other side. And already this should start looking a little bit like the circle equation. We have an x squared with something, we have y squared with something, and then our radius squared on the other side. Okay? But it's not quite right yet. To put it in this bracket form here, okay, having a look at this, we're getting pretty close, is we can complete the square. Okay? And we're going to complete the square for this component. We're going to have to do one completing the square, and then we're going to have to complete the square for this component as well. So we're doing 2 complete the squares. Okay. So for the 2, this is I'll go to red. This is our magic number. So remember to find what we're add, subtract. It's going to be that number b. We go b divided by 2, square it. So 2 divided by 2 is 1, squared is 1. Add 1, subtract. We do the same with this 6 over here. Okay. Where we go 6 divided by 2, all squared, so 3, all squared is 9, so we add 9, subtract 9. So you have to do it for both sets. Add 9, subtract 9, and then you are going to start the factorize. X minus 1 squared from that part, we get that from completing the square. From this part, we get that, and then we have our minus 1 and our minus 9 left over. What do we do with the minus 9 and the minus 1? Okay. Well, we're very, very close to the standard form of a circle now. We actually just need to move them over to the other side, simplify, and bam, we have it in standard form. X minus 1 all squared, y 3 all squared equals 25. So in this case, we have h equal to 1, a is equal to negative 3, and radius is equal to 5 square root. Replay that if you need to. The idea is that we're almost breaking the problem into 2 parts. We're splitting it here. We've got our x form of a quadratic, okay, and we have our y form of the quadratic. We're going to complete the square for both of those, factorize y. So there's 2 completing the squares going. So let's have a go and let's do a sketch. So first off, I'm going to bring my x squareds together, or my x's minus 4x, bring my y's together plus y equals 11. Okay, now I'm going to complete square for the x, so we get x squared minus 4x. Now halve 4, which is 2, then square it is 4, so I go plus 4 minus 4. Do the same for the y, plus 2y. Okay, halve our magic number is the 2, so halve the 2 is 1, then square, so 1 squared is 1, so plus 1 minus 1 equals 11. Okay, now I'm going to start factorizing this, completing the square, so we get x 2, okay, and then we have minus 4 in the end, plus have y plus 1. Ooh, and got clear off that. Okay. and r minus 1 equals 11. Now we're going to bring the -4 and the -1 over to the other side, so we get x plus 2 all squared plus y plus 1 all squared equals 11 plus 1 is 12 plus 4 is 16. So let's write down from this our key values. We get h is equal to 2, k is equal to -1, and our radius is square root of that. So let's start putting in some values. H is equal to 2, so we go across 2, down 1. There's our center. I'm going to label that. That is 2, -1. Our radius is 4, so this is our compass point. Okay, I'm going to find a point up 4, across 4, down 4, and across 4. So up 1, 2, 3, 4. There. Across 4. 1, 2, 3, 4. Down 4. And across 4. Okay. There I have my compass point. So now I can sketch in, and this is probably not going to look very circle. There we go. Okay. Not too bad. It's a bit squished, but not too bad. Okay. We don't need to label those compass points that we've just put down to help guide our sketch, but we do need to label our radius. Okay. So our radius is 4. Okay. Now the last thing to do is our intercept. So I'm going to go in and mark those where they all occur, so I know how many I need to find. So in this case, I need to find 4. I'm going to do the exact same thing as we did in the other problem. So, okay, so for our y-intercept, we let x equals 0. We get now. No. We'll use in this general form. That works out easier. You could use this form. You could substitute it into it but you then sort of end up needing to factorize anyway. So use this form. It makes it a little bit quicker. So we're letting x equal, so we get -2 squared plus y plus 1 all squared equals 16. So that's 4. Take away 4 from both sides, so we get y plus 1 all squared equals 12. We get y plus 1 equals minus root 12. We get y is equal to plus root 12 minus 1. Let's simplify this third, because that's going to be 4 times 3, so we get plus or minus 2 root 3 minus 1. That was my y-intercepts. So this is going to be 0 to root 3 minus 1, 0, -2 root minus 1. X-intercepts, let y equal to 0, so same thing. We 2 squared plus 1 squared equals 16 x 2, and I'm going to start skipping some steps here. Equal plus or minus the square root of take 1 from 15 from 16 is 15, so we get x equals plus or minus square root 15 plus 2. Square root 15, we can't simplify that third. Okay, so label those in. So this would be root 15 to 0 would be -15 plus 2, 0. And there we are, done. Okay. So there's a little bit of work involved, but overall the process isn't that hard. Right, this is where it gets a bit complicated. Semicircles. Semicircles, and I can tell you from previous years, people get these really confused with square root graphs. Okay. Let's have a look through this and then I'll tell you how to identify when it's a square root graph and when it's a semicircle graph. So if you recall, we looked at square root graphs with the rule y equals plus or minus square root x. We were only expected to sketch either the top or the bottom half. This applies with circles. Okay? If we rearrange the general equation of the circle, x squared plus y squared equals this, to make y the subject, it gives us y squared equals r squared minus x squared. Okay? If we take the square root off, square root both sides, we get y equals plus or minus square root of r squared. If you sketch this and you sketch the positive version and the negative version, that would be a full circle. Okay? So what's going to really happen is you have positive bit, and have the negative. Okay, and if you sketch both of them, just as we proved, because it's just come from this, so that is a circle. So if you sketch both of this, it will look like a circle. But if we write them separately, we just take the positive, that will be the top half, like I've just drawn, and then if we take the negative, that will be just the bottom half of the circle. Okay. Now, as it says in here, we have this r squared minus x squared all under the square root sign. No, we can't cancel out. We can't cancel the square and the square. So, because they're not similar. Or like so. Okay. So this is what we end up getting. If you rearrange that basic one here, you rearrange that to make y the subject. Got y the subject here. If you take the positive square root, we get the top half of this. If we get the negative square root, we get the bottom half of the circle. Now you could also rearrange this equation back on the previous slide here. You rearrange that to make x the subject. We actually get the right half of the circle and the left half of the circle. Now all of these have a square root sign in it. And I said before, and it looks very much like a square root graph, what we've seen in general form. How do you know it's different? We have a squared term inside the square. We have a squared term inside the square. Squared term inside the square root. As soon as you see a squared inside the square root, you know it's a semicircle rather than the square root graph. Because if you go back all the way, where's the square root one? Here. It's of order 1. It's just an x, it's not x squared. So that's how you tell the difference. So let's do a sketch of these. So first off, we've got an x and positive. So the way I read this, the way I look at these, when I see, it's a square root with a squared term in it, that's going to be a semicircle. I have an x and positive. That means I can think of, I'm going to be dealing with x values. Now, there may be some negative x in here, depending on translations, but I have an x value positive. That means I'm going to be getting positive x values. That means, think about, I'm going to be dealing with over here. That means I'm going to have sided right hand. That's how I think about when I read these graphs. Same here, I have a y negative. That means I'm going to be dealing with down here negative y values. That means it's going to be look something like this. It might be translated up or down or left and right, but that's what I think when I read graphs. Coming back, we have our r squared term. So in this case, 9. So cool. Not translated, so its center is there. Go. Oh no, not that. Go out 3, up 3, go down 3. I'm not going to go left 3 because it's a semicircle and on the side. Oh, that's a terrible. And the nice thing about this is we still label our center 0, 0. Okay. And our intercepts are really quite easy. 0, 3, 3, 0, 0, 3. Same thing over here. Okay. Talked about it before. I read Y, negative sign. That means I'm dealing with negative. Okay. My R squared is equal to 1. So R is equal to 1. My center is at 0, 0. So label that. Go across 1, down 1, and right 1, not up 1 because semicircle. 1, 0. 0, neg 1, neg 1, 0. Done. Okay. Oh, I forgot. Radius equals 3. Radius equals 1. Got to draw them. Alright, getting to the end. We're getting to the end. Like all the other graphs we've looked at, semicircles we can also translate. They can be moved around the axis. Same process we've used. We have a H and we just need to find it. Okay. Before I go any further, I'm going to jump to the note down the bottom here. Okay. We only deal with transformations of Y equals semicircles. Okay. So we only deal with a top half or the bottom half translation. We can do the left and right without translation when it's an X equals, but for Y equal, if we're going to include translation, we just Y equals, okay, top and half, top and bottom. Okay, so the general form of a semicircle, top half or bottom half, is Y equals K plus or minus square root of R squared minus X minus H all squared. Okay. Same thing, find our translations, that gives us our center, find your radius, find any X and Y intercepts, establish the correct slides, plot the points, and so let's have a go. Straight off the bat, okay, I have a -3, so K is equal to -3, my R squared is equal to 16, H is, and in this case K's sign's not swapped, the H is swapped, we have H is equal to R equals 4, we have that. Now, what type of graph? Is it going to be a top half or a bottom half? Well, I read it, I have Y, so it's going to be a top or a bottom. And I skip this sign, I'm looking for the sign in front of the square root, it's a positive. Okay, that means it's going to be graph. Okay, so get rid of that. So our center point is at -1, -3, so -1, 3 there. I'm going to plot that in. -3. Okay. Then I'm going to mark in my key points. So my radius was 4, so I'm going to go across 4 to the left, 4, up 4, and across 4. Okay, I don't go down 4 because I'm just, like I said, dealing with the top half. Now I'm going to roughly sketch in. Ooh, that wasn't. Let's see if I erase it. That works. Something like that. There. Going to radius equals 4. All I've got left is the intercept. Okay, so let's do a y-intercept by letting x equals 0 like normal. So we get y is equal to negative 3 plus the 16 minus 1 squared. So I've let x equals 0, so we get negative 3 plus the root of 15. Okay. Can't simplify that third anymore. So that is 0 root 15 minus 3. That, so we do our x-intercepts. We let y equal to 0. And I'm just going to start solving this. Hopefully by now you're with this. So we take the square of both sides. So we get 9 equals 16 minus x plus 1 squared. We're going to get x plus 1 all squared equals 9 7. Get x plus 1 equals this plus or minus the square root of 7. I'm just up here. We get x equals plus or minus the square root 7 minus 1. And we just go and label those points in. So that would be root 7 minus 1, 0. And then this is negative root 7 minus 1, 0. And that's your semicircle done. Okay, so very much like the circle, just got to start recognizing. And that's it for exercise 4D. If you have questions, please ask them in class. Thank you very much.